10.3, displaying data, part 2. It's almost like part 3 because we've had 2 days of displaying data, part 1. It's always weird to title these sections. So we are going to continue looking at ways to give information about data by way of a graph. And these are separated on purpose to be done this way. These graphs are less about comparing categories of things and more about comparing how something's changing over time. Okay? So our first one we're going to look at is a line graph. A line graph is made up of line segments connecting one data point to the next, typically showing the trend of a variable over time. So you want to think like connect the dots, right? Like the kids' menu stuff at Chili's or whatever. Connect the dots. So you're connecting line segment to line, or you're connecting point to point with line segments. So the example that we're going to look at is a time example, and it's an amount of time based on the time or the day of the week. So a learning specialist tracked the average reported study times of her students, and we're going to create a line graph for the data she tracked. So these are studying times, right? So on Monday they studied an hour and a half, Tuesday an hour and 1.75 hours, an hour and 3/4. Wednesday 0.75 hours, Thursday 2 hours, and so forth. And so we're going to create a line graph to show this information. So you're going to create like an XY ordered, like a XY plane. And on the bottom, we're going to use the Monday through Sunday. So feel free to abbreviate, right, just by the first letter of the week or the first couple of letters if they're not distinct if you'd like. And they should be equally spaced. So here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then the axis, or the vertical axis over here, is going to represent study times. And unless there's a reason not to start at 0, we tend to start at 0. So looking at our study times, these are all study times that are close to the number 0, right? I mean, it's not like we're talking about like 15 hours and 16 hours and 14 hours and 13 hours, right? They're regular, not regular, they're small numbers close to 0. So it does make sense for us to continue using values down here that are close to this. They're all represented in quarters of an hour, right? So the first one being 0.25, and the second one being 0.5. And again, equally spaced, 0.75, at least approximately. We have 1, we have 1.25, 1.5, 1.75, 2. Is 2 the biggest number? I think it is. And if you feel like this felt a little cramped to write everyone out, you don't have to write every data value down on the left. You need a hash mark for it. But you are welcome to just like label every other one or something like that. That would be fine too. Okay, so we're going to do our best to be in the right row and column for our dots. Okay, so try for accuracy in what you're doing. I will do my best to do so as well. So on Monday, we have 1.5 hours. So we're at a height of about right here on Monday. Tuesday is 1.75. So we're slightly higher, about right there on Tuesday. Wednesday is 0.75, probably because they went to church. Thursday is 2 hours. So Thursday, 2 hours, undoubtedly studying for Friday tests. Saturday, 0.25 hours. They're probably lying. Don't know many kids who study on Fridays. Not a normal day. Saturday, 0.25 hours for exactly the same reason. And then Sunday is 1.5 because you got to make up somewhere along the way that you didn't study when you should have. Right? Pretty much. So we're going to connect these with a line segment. So we're going to connect from day to day. So Monday goes to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, Friday to Saturday, and Saturday to Sunday. So my thing likes to connect the dots sometimes a little funny, so that's not too bad. This is a line graph. It's not a line. It's a bunch of line segments, right? It's important. What do I still need based on what we've done before?
Title.
A title would be one of those things. What could the title be?
Hours spent studying.
Sure. So hours, or you can even say time. So hours spent studying. What else am I missing?
I have to label the sides.
I need to label my axes, yeah. So on the bottom, what is the bottom axes representing? Days of the week. So we'll write it. Days of the week. What about my vertical axis?
Hours.
It's hours. Yeah, you could say more generally like hours spent studying if you want, but at the very least we need to label that it's hours because we've got the spent studying part somewhere else. So if you want, write more, but I'm going to at least write that this is hours on the side. Okay? Any questions on that one? Okay, people usually like line graphs. They're very comfortable. The next one's a little trickier. The next one's a scatter plot. And interconnected with scatter plot is something called a trend line. So scatter plot is often used when a relationship between variables cannot be easily depicted even by a broken line. You usually tend to have a lot more data. So imagine that we had this child, right? This child gave us all this information about their line chart, right, their line graph. But you had 15 kids giving you dots everywhere, right? Every kid gave you a value for Monday, and every kid gave you a value for Tuesday, and every kid gave you a value for Wednesday. You end up with a lot more data, and you can't really depict it very well with a broken line because it's so big. The data is so big. That's usually when we see scatter plots being used. So we have an example here. Coach Lewis kept track of the vertical jump heights in centimeters of his starters over 8 years. Okay? And that's what you see. A lot of data, right? So we have year 2002 all the way up to the year 2008. We have all 5 of the starters on the team listed there and the heights that they jumped during those times. Now, it's probably important to realize that that first line is not all the same person, right? It's one of the 5 people on the team, but the 5 people on the team are ever changing. At least every 4 years, you're going to get a whole new group of people, right? So, yeah, it's important to sort of think through that. So we're going to do a vertical, we're going to do a scatter plot for this in just a second. But I also want to talk about a trend line because it's highly connected with scatter plots. So a trend line is not a line graph, but it is a line. It is a line that closely fits the data, as close maybe as it can anyway, and can be used to describe it. And sometimes you hear it referred to as a best fit line or a line of best fit. So what we're going to do then is we're going to draw a scatter plot. It doesn't say this here. I don't have it written in my paper. You have a spot for it. It says draw a scatter plot for the data, and then describe the kind of association. So I need to use my slides at the end anyway, so I'm going to flip back over here. Okay. You do not have a grid, and I'm sorry for that, but this is one of those ones where it's going to be a lot easier for me to do it on a grid, so I have one. If you have graph paper, you're welcome to use it. We mentioned that last time. So I'm going to draw a vertical and horizontal axis in. And I'm going to mark my x values at the bottom. I'm going to spread them out just a little bit to give myself some space to work. So I'm going to start with my axis. There's a very specific reason I'm going to do this, but I'm going to start with my axis being the year 2000. I need a starting spot anyway. We talked a moment ago about the fact that we don't want to start at year 0 because it doesn't make sense for our data, right? I did want to start at 0 for my times because it made sense. It doesn't make sense here. So I need to start with something that does make sense. So I'm going to start with the year 2000 because my data value started at 2002. So the year 2000 for my vertical axis is a good place to start. And I'm going to skip like 2 lines, my 2 little hash marks. I'm going to make this the year 2001, which I know I don't have any data for, but I still need a representative of it for spacing issues. And then this would be 2002. Then I have 2003. I have 2004, 2005, 2006. Did it go to 8?
Mm-hmm.
Okay, 2007, and 2008. My writing got bigger. It's right across there. Isn't that fun? Okay, we have to put a bunch of dots on this thing. Okay? So you're going to be flipping back and forth or disconnect your pages and restaple them later, depending on how things are printed out for you. And we're going to put the data values on there. I don't have the ability to do that quite yet. I need to do my axes, the other axes. The other axis is supposed to be, hang on, let's do this. This is years down here. And then over here, these are my, hang on. Vertical jump heights. And it said it was in centimeters, so we'll label it centimeters. The values in my chart, though, are values that are in like mostly the 60s and 70s. Mostly the 60s, right? So I don't really want to start at 0 because I don't really want to have values like in the 10s and in the 20s and in the 30s. I don't need those values on this chart, right? So I don't really want to start my chart at a height of 0. I need to start it somewhere else. What we're going to do is something that's a little bit unique to the, not a little bit, it is unique to the y-axis. We're going to do what's called a break in the graph. So we're going to do like this. And it tells you that 0 is the number on the bottom, right? It is the number on the bottom, but we're going to sort of jump up and we're sort of collapsing that space down because it's not necessary. We don't need those values. So we're going to actually start at values that we do need. So what is the lowest value on the chart? 58. So I'm going to start at 58. So the first mark I'm going to make is 58, and I'm going to label every other one. So 58 and then 60. I'm not even sure if I have space enough to do it that way. We'll try. If I don't, I'll have to go back. And then I have 62. I have 64. 66, 68, 70, we're awfully close, 72. How far high do I need to go? Let me just barely not.
77 is the highest.
77. I'm shifting mine down. I think that might be enough. The year 2000 is off of my thing. I can get that back on. Okay. 72. I have 74. 76. 77 is my very top line. Almost don't have enough. Okay, so here's what we're going to do. We're going to mark a dot at every height mentioned in 2002. So in 2002, I'm going to make sure I'm on the 2002 line and not the 2001 line. I have a 65. I have a 63. I have a 60. I have a 62. And I have a 58. Okay, everybody tracking with me on what we're doing? And then we're going to jump over to the year 2003. So the year 2003, we're going to have the next set of data values, 67, 65, 64, 66, and 62. And then the next one I have 67, 68, 66, 65, and 64. I have 68, 70. Six, 67, 69. And 66. I'm off one. And 2005. Hang on. 68, 70, 67, 66, and 65. There we go. Now I'm at 70, 68, 67, 69, and 66. Oh, that one was supposed to be there. Actually, that was 65. This was 66. Okay. 74. Oh, dear. 74, 72, 73, 70, and 69. And then I have 77, 75, 72, 71, and 70. Scatter plots are intense. Okay. Okay, so there is a question that says create scatter plot. Even though it's not written on my screen, it's on your paper. It also says what kind of association is this? So association means as you move from left to right, does the graph go uphill? Does it seem like it's increasing? Does it seem like it's decreasing? Does it seem like it kind of just bounces all over the place and there's no association? What happens in this graph? It looks like it's increasing, right? It looks like it's moving from the bottom left to the top right. So the association that it's asking us for here is that it's a positive association. Positive means that as the x value, right, increases, sorry, as the years in this case increase, as the years increase, the vertical jump height also increases. They do this in a positive relationship. One increases, the other one increases. Now, that's it for a scatter plot. So if you are asked to do a scatter plot, this is what you're doing and you're done. Okay? That's the question about scatter plots. But if you take a look on number B, that's not a number, letter B, it asks you to create a best fit line, for example, 3. A best fit line means finding a line that seems to sort of mimic what the behavior of the data is doing. It's going to go through the points and be in the same general direction that the points are moving. Okay? So, as we're drawing this, I'll change colors. We'll go with red. And I want my line to sort of look like what's happening in my data. And kind of cut through the middle of it. It should look like it's balancing and the same number of dots approximately above the line and below the line. So there's going to be a little variation because we're not doing this from a purely mathematical standpoint. We're doing it from an approximation visual standpoint. So my graph's not going to look just like yours. Your values that you get when you create this lines equation are probably not going to look exactly like mine. But they're going to be close. If they're not close, then one of the two of us have made an error in what we've calculated. Okay, so this is approximately the line we're talking about in 3A. But B says it wants us to give an equation for this line. How do you find an equation for a line? Well, if you've drawn it all the way over to the y-axis, that's a good thing, because it means it crossed over here somewhere. Now, mine's crossing at 59, almost perfectly. If yours isn't, that's okay. It's still probably pretty close to 59. Is it? Where's your graph crossing on the y-axis? Audience participation time. What do you got? 57, 50. Yours is at 59? 57? Okay. So those are all good values, right? If you gave me something like 42, we've got a problem. Right? 67, we've got a problem. So we're looking at values that are going to be close to 59, 57, something like that. So when we write our slope of our line, our equation of our line, what we just found is called the y-intercept. So this is y equal mx plus b that we're trying to fill this in for. The plus b part is the part that matches your picture. Mine is 59. Some of you said that yours is 57. Whatever it is, that's what goes at the end. Okay? Plus that value. M is the slope. Okay, in my case, I've got a grid where I can count it out, and that's lovely. I can count it. I can count how far up did it go, how far over did it go. It's great. I'm going to do that, but then I'm going to show you what happens if you don't have that, which is the case most of you have. Now, you need points on your line, not just random points on the graph. It has to be points that are coinciding on your line. So on mine, it's very nice for me to use this one right here at the beginning. In fact, yours probably is pretty nice as well. If it's not, then don't use it, right? If it looked like it was crossing at 57.5 and you don't want to use it, then don't use it, okay? So I'm going to use that one, and I'm going to use another one where it looks like it's crossing kind of at a corner. That one looks pretty good. So if I want to, I could actually count. I can go up 1, 2, 3, 4, 5, 5. Or is it 5? And I can go over 1, 2, 3, 4, 5, 6. Up 5, over 6. It's rise over run. Mine's about 5/6. Okay? Hang on just a second. Oh, I apologize. My over 6 is not over 6. It's because they were each measuring years by 2s. So I did go over 6 hash marks, but 6 hash marks represents 3 years. Mine is over 3. Are you guys with me? It's like that's not the number it should be getting me. I'm actually 3 years over. So I've gone 1 year, 2 year, 3 years, 4 years, 3 years right here, 3 years over at 2003. Okay, so my slope's 5/3, the way I've graphed it. So over here, I'd have 5 over 3 and then x. Okay, so if you don't have points that you can count like mine, what do? Well, you just take values from your chart. So you can still take those values I circled in blue, and you figure out what those values are. The first one is the year 2000. And the year 2000, I'm at 59 on my graph. And then the second one is the year 2003, and I'm at the y value of 64 on my graph. Those are the points. And you find your slope by doing y2 minus y1 over x2 minus x1. Y is the y-axis. It's my heights, right? X is my x-axis. It's my years. So my years are on bottom, 2003 minus 2000. My heights are on top. It was 64 minus 59. So I'll end up with the same 5 over 3, but from an algebra perspective instead of from a graphical perspective. Now, I'm kind of done with the equation, kind of. The problem with this equation, the way it's currently written, is that it's not usable for future information. Let's say, for instance, I wanted to know, using this equation, well, what are the jump heights in 2009 or 2010? There's nothing here that says what x and y are, right? So I need to actually say that x is the years after 2000. That's why I chose a starting year that was nice. All right, so if I want 2009, I'm going to put the number 9 into my equation, and I can do this. And I can get the value. And then y tells me what I've got out when I'm done. This is the vertical jump heights, or height, in centimeters. So I need labels on the equation. Now that said, I need to go back and do one more thing on my graph as well that I haven't done. What do I need to do on my graph? I did get my labels. You could add an XY, but that's not necessary. What is? Somebody said it though. A title. I don't have a title here. So these are the vertical jump heights of Coach Lewis's starters. Something like that anyway. So I made a note on your example B that's already written in. You must have appropriate supporting language, labels, in order for this equation to have any meaning. So if I ask you something about this on the test and you don't have that label, the x and the y, you're going to have to redo the problem because that's so important for it to be able to be used for anything. Because that's what we're going to do on part C. We're going to use our equation to predict the jump height this year. It's going to be silly because it's a big number, but we can still do the process. So what is this year? What's our year? 2023. So if we're doing from 2023 and the starting year is 2000, how many years past has this gone? 23, yeah. So x is 23. That's what we're going to be putting in. So I'm going to put 23 into my equation. You're going to put 23 into your equation. So I have 5/3 times 23 plus 59. Did you get 97.3 repeating? Well, if you used 59 and 5/3. If you didn't, did you get something kind of close to that with your equation, whatever your equation was? Should be close. This is a number of centimeters. It's so much larger than the ones that we've done. What we did is a process called extrapolation. Extrapolation means getting values on the farther out than your data set. If you do stuff within your data set, it's called interpolation. So when you're finding values in between, like let's say, for instance, that you wanted to say, well, what's the predicted jump height of the starter in 2004? Well, you could do that, and it'd be really close to the right values because you're right in the middle of all your data, right? But anytime you go farther enough outside of the data set, it becomes less reasonable of a estimation. Okay, there's only a couple things left to do. So let's take a look. We're going to take a look at association. So we talked about association in terms of a graph. We said if the graph increases from left to right, if you're increasing x values and the graph is increasing in y values, that's a positive association. Its slope is what we're talking about, right? So if you have a slope that's positive, you have a positive association. And if you have a slope that's negative, you have a negative association. So what kind of a association do we have when y is equal to negative 2x plus 3? It's negative. 4x minus 3? It's positive. Okay, the last one just says y equal 8. There's not a slope that's written down, right? It's not zero association. What we actually say is that there's no association. And what it usually ends up looking like is a bunch of dots that if you were to draw a line, it kind of would look horizontal because you can't really say that it's going uphill or downhill. Hence, a horizontal line looks like a zero slope, right? So as you're taking a look at these, there's going to be some in your homework and your group work that want you to draw a trend line from a data set that they give you. If you just put your paper onto the data set, I don't need you to draw all the dots, okay? You'll be able to see the dots through the paper, and you can still draw your trend line without drawing all the dots, okay? That's the one caveat to thinking I want to make sure you saw.